Okay, welcome. I'm going to spend this video going through the cast diagram, and in this video I'm going to go through the same questions that I went through live with those people in the lesson. So we're going to focus on the cast diagram, then look at some coded questions, then look at how to use trigonometric identities to help you out. So first of all, this is something you should already hopefully remember. The reason we use the word cast is it helps us remember what is positive in each section. So in the first quadrant between 0 and 90, you can see that all sine, cos and tan are all positive. So that's why A is in the top right hand corner. Sine is the only one positive in this section, which is why there's an S. Tan is the only one positive in the third quadrant, which is why it's a T. And cos is the only one positive in that section, which is why it's called cast, because it tells us where is it's positive and where it's negative. So if you need to make any notes on this page, you can pause this video as you go, but I am going to go through. So the three examples I'm about to do is to look at one, making sure you can know the basics of cast, and to see some of the twists and turns that come up. So to start off with, this is our equation. And the first thing we need to do is on our calculator, we're just going to inverse 1.2 to get our starting angle, which is 50.19. Now, if I was going to give my answers to one decimal place, at this point I would write it down to 2 decimal places. I like to have an extra decimal place before I start. Key things. First of all, I can see here that we're dealing with tan. So tan is positive in the T section and the all section. It will be negative in the other two. The next thing I look at is I need to know which section I'm drawing it in. So I look at the angle. If this is positive, draw in the plus sections. If negative, you're going to draw it in the negative sections. Okay, now all angles are always drawn from the x-axis. If you notice on my cast, I haven't even labelled the y-axis. It's because I don't use it. I only use the x-axis. So I have a positive angle. I'm going to draw it in the positive sections, labelled from the x-axis. And the angle was 50.19. So my solutions. My first solution, starting at 0, happens here. How far have I actually turned? Well, that's 50.19, or we can now give it to 1 decimal place, so I'm going to say 50.2. For the second solution, again, starting at 0, how far have we turned? Well, getting to this line here gets us to 180. So if I do 180 plus my 50.9, again, now I'm going to round it to 1 decimal place for my final answer. I get 230.2. So do make sure if you need to make extra notes or you want to have a go at some of the questions before me that you do pause the video. So the next one, I want to show you how to make sure you know how to deal with a negative angle. So I start off just as I did before, and I'm going to do the inverse side of minus 0.4, which gives me minus 23.58. We are dealing with sine. So sine is positive here and here, negative at the bottom. I now have a look. I have a negative angle, so my angles will be drawn in the negative sections, always measured from the x-axis. When I label my angle in here, I don't put the minus in. The minus is just telling me where I'm drawing it. But that angle is actually 23.58. The minus is just telling me which sections I am drawing this in. So my answers are, so starting at 0, I'm going to spin around, and I can see that I've turned 180 degrees plus another 23.58. So to one decimal place, that is 203.6. Then again, starting at 0, how far have I turned to get here? Well, if I turn all the way, that's 360. Then I can take away my 23.58. Now on my calculator, that says 336.42, but I'm now giving my answer 336.4. Notice the answer I got from my calculator is actually not one of my answers, because I only want answers between 0 and 360, and that one was outside my limits. Now, what's brilliant about cast diagrams is I don't have to draw things to scale. And this is a classic example is where some people can confuse themselves. And if you follow what I do here, it does make your life easier. So start off, as I always do, I'm going to inverse cos the number. Now for this one, I am going to write it as, two decimal places, so that's 1.16. Now that's an obtuse angle. Don't let that throw you. It's a cos, so positive here, here, negative here, here. I don't care what the angle is. I often just draw it. It's a positive angle. I'm drawing it in the positive section. It does not matter that it's not to scale. You don't lose a mark if it's not to scale. We have an angle in the positive section labelled 154.16. You will see me sometimes when I do questions. I would happily draw an angle and even put 90 degrees there. That's okay. I'm still going to end up with the right answers. I've also been known to even put these lines on and even put a 0 angle so I can check what the other solutions are. It is fine. That's what's brilliant about a cast diagram. You do not have to draw things to scale. So, look at my solutions. Here I can read off one of my solutions to one decimal place is 154.2. And then I'm going to do 360, take away 154.2, which would give me 205.8. Now you can draw on scale if you want, but the key thing is you don't have to, which is really good. What I now want to talk to you about, sorry, I jumped ahead of myself. I'm forgetting what slide comes next. Now what I suggest you do on this one is have a go at this one without me. Pause the video and then replay the video when I go through it. Okay, so hopefully you've unpaused and give this one a go now. So before I start, I'm just going to get it so sine theta is the subject. Here we go. So I'm going to do my inverse sine is minus 39.8. So sine is positive here and here. It's a negative angle, so I'm going to draw it down here. So your solutions, if we are going between 0 and 360, your solutions should be 180 plus 39.8 and 360 minus 39.8. Now, before I move on to another example, what I want to do is show you, make sure, because this is where I know the people I've taught this year when we had issue. I'm just going to change the limits. The limits now are going to be minus 360 to 0. Just to make sure we know how to go backwards through a cast diagram. There's different ways to do it, but what I like to do is I like to start at 0 and I'm going to work backwards around. If I go anti-clockwise, that's classed as forwards. So I'm going backwards around because I'm going clockwise. So at 0, I'm going to go backwards 39.8. So in this example, I would actually get minus 39.8. And then I need to go backwards to here. So if I go all the way around to this line, that's minus 180. And then I need to kind of go forward, so I'm going to add 39.8, and that will give me minus 140.2. So hopefully that makes sense where I get the two values from when I go negative. I now just want to recap what you did with a coded question. This is cast as a coded question because inside the trig, it is not just an x on its own. Now, I had my year 13s this year did a test, and their first question, this was all the way back in, I think it was October, and the first question was a coded question. And at the year group, the entire year group who sat that test, I can count the people who got it right on one hand. It's really important that you spot a coded question and know how to deal with it. So, first thing you always do, always check and adjust your limits. I have a 3x here and only an x there. So each part of my limits need to be times by 3. They are my new limits. I am now going to start solving the equation. So I'm going to inverse cos 0.2 and 2 decimal places because I'm going to give my final answer to 1 decimal place. It's really more important on these ones than the previous ones. I get 78.46. Whatever you do, do not divide by 3 at this point. If you do, you're going to lose marks, lose answers, and probably only get the maximum of 1 mark on this question out of a possible 3 or 4. The last thing you're going to do is get the x on its own. If you do it now, you are guaranteed to drop marks. So, I'm now going into the cast diagram. We have cos, which will give me this, and it's a positive angle. I will draw this in the positive section. Now, I've got to get all the way round to 1080. So I've got 0, 180, 360, 540, 720, 900, and then I get to 1080. So I'm going to spin round this diagram 3 times, which I can already see if I go round 3 times, I'm going to get 6 solutions. If you divided by 3 first and then cast, you will not get 6 solutions. If you do get 6, they're not 6 correct ones. So what I do is I'm going to actually work out the 3x solutions, values from the cast, and the other answers at the same time. So I can see the first answer I'm going to get is 78.46, and I'm going to divide that by 3, and as I want my answers to 1 decimal place, I get 26.2. Now, if you had rounded this to 78.5 and divided it by 2, you would have actually got 26.3 on this line to 1 decimal place, which would have been wrong. This is why I keep the extra decimal point in. So my next answer on my cast diagram is 360 minus 78.46. That gives me 281.54, which I'm now going to divide by 3, which is 93.8. So I've gone round once, so I'm now going around my second time. So I've got 360 plus 78.6. So hopefully you're doing this on your calculator as well to make sure you get the right answers. And I'm going to divide that by 3 to give me 146.2. So I've now spun round once. I'm now almost at 720. So I'm going to do 720 minus 78.46. So I'm going to have to go on the next line because I was running out of space. And I'm dividing by 3. Yeah, this takes time, but there are definitely marks available for it. So 213.9. Oh, sorry, 0.8. I said the wrong thing. Writing the right thing, but said the wrong thing. Okay, we're almost there. So we need to do 720 plus that number, which gives us 798.46 divided by 3, 266.2. And I'm now going to do the last number, 1080, take away 78.46, which is 1001.54, and divided by 3, 333.8. So if you look at the bottom, we have ended up with 6 answers, and the 6 answers are between 0 and 360. What I'm going to go on to next is a reminder of the identities and the sort of things I do so I know which one I'm going to pick. So the 2 identities you have, the first one, sine squared plus cos squared equals 1. And the second, sine over cos equals tan. Now, this one, in all the years I've been teaching, I can count the number of times I've rearranged this equation on one hand. Don't be tempted to rearrange this one. So I don't write tan times cos equals sine, and I don't write sine over tan equals cos. You don't need to. Leave it as just sine over cos equals tan. This one, however, I will rearrange. Sine squared plus cos squared equals 1, but also I can know that sine squared equals 1 minus cos squared. And I can also see that cos squared is 1 minus sine squared. So this I use a lot if I need to change sine squareds into cos squareds and cos squareds into sine squareds. So make sure you have a copy of those 2 identities I've got in the bubble before you move on to my next example. So here's the one I'm going to look at, and I'm going to make this one a bit more fun. I'm actually going to do this one between minus 180 and 180 because I think that would be a bit more fun. Okay. The first thing I'm going to look at is, does it have any squared signs? Okay, it doesn't. So it hasn't got a squared sign. So I'm going to try, so that tells me I'm going to use this identity. So what I want to do is be able to create a sine over cos. So I can do that by dividing both sides by cos. I've divided both sides by cos. So on this left-hand side, using my identity, it comes out as tan. On the right-hand side, cos divided by cos will just cancel out, leaving you with 3. And at this point, you would have already had a couple of marks. But now we're in a point where we can actually solve and cast. So I can see here, the theta would equal 71.57. And I'm going to go with the cast. It's a positive angle. So I've got positive here and here. I'm drawing that in the positive section. Here and here. Now, I'm going to start at minus 180 and go all the way around to 80. So as I said, when I go backwards, I do still like to start at 0. So if I go backwards from 0, I go all the way to here. So all the way to minus 180 and come back. So minus 180 plus 71.57 gives me to 1 decimal place minus 108.4. No, so it'd be a minus there, minus 108.4. And then I've got to go all the way to 180, so I can see I'm at 0. And I'll get my other solution, which I'm now going to round to 1 decimal place. And these are my 2 angles. So make sure you've got notes on that before you move on to the next slide. Okay, for this one. Now, unfortunately, if this was both sine or this was both cos, it makes your life a lot easier. Unfortunately, we got one of each. That's what tells us we got to use an identity. And because I see a squared sign, this is the identity that comes to mind, because there is a squared sign. So we have a cos squared here, so I'm going to make cos squared the subject. So cos squared becomes 1 minus sine squared. Now, because I've got one term that's squared and one term that's not, this is a quadratic equation. So I'm just multiplying out my brackets, and for quadratic equations, I do need it to equal 0. So I'm just going to bring that 1 on the other side, which will give me a plus 1. Now, you won't get any marks at this point for factorising or using the formula or anything like that. You're expected to just use your quadratic mode on your calculator. And that is how I can get the answers very quickly, as sine theta equals a half and sine theta equals minus 1. If you do not know how to use your calculator on this line on quadratic mode, so I've just used the numbers in front, a minus 2, a minus 1 and a 1 in quadratic mode to get the answers, do ask your maths teacher. It's imperative that you know that mode because it will save you time, and you've got to remember everyone else in the year group is going to be using it. So if you don't know how to access it, ask your maths teacher. So at this point, I get two solutions. Now, sometimes you might get one of these that say math error on your calculator. If so, you just write no solution. It does happen sometimes. So because I've got two answers, I need two cast diagrams. We're dealing with sine. So we've got positives here and here. So for the 30 degrees, that's going to go in the positive section. And that will give me the answers of, if we're going from 0 to 360, I'm going to have 30 and 180 minus 30, which is 150. For the other one, minus 90, and again, I don't draw things to scale. There's my minus sections, and I'm drawing my 90 in. I've got 180 plus 90, which is 270. And then I've got 360 minus 90, which is also 270, which means we have three answers. Now, for the last example I'm going to do, this is actually from a past paper. It's a 5 marker. So if you wanted to have a go before I go through it, please pause the video. I'm going to start going through it now. Okay. Now, there are two ways to do this one. So I am going to show you both methods, depending on which way you decided to do it. Now, the easiest way to do this is to actually see, now because you've got a tan in here and sines and coses, again, I'm going to write this identity down. So, and I don't like it when there's sines, coses and tans. So one method to do this is to create a tan, create a sine divided by cos. So what I'm going to do is I'm going to divide every term by cos, and that will give me a sine over cos here and a sine over cos here. So this all gets divided by cos, so is this, and so is this. So over here I've got sine divided by cos is tan, and a tan times a tan is a tan squared. I've got lots of sine over cos, that's another tan. And then the coses here cancel. And I'm just going to, again, I've got a quadratic that I'm going to make it equal 0. Using the quadratic mode on your calculator, again, I can get the answers very quickly. I get tan theta equals 1. And tan theta equals minus 3. So from here, I can get theta equals 45. Sorry, I missed off the minus from my 3. And minus 3, which is minus 71.56. Now here it says to the nearest degree. So down here, I'm going to keep it to 1 decimal place for the moment. So I've got 2 answers. 2 answers mean 2 cast diagrams. So on here, I have 45 degrees and 45. So from this diagram, I'm going between 0 and 180. So I only have 45 degrees. The other one takes me above 180, so I'm going to ignore it. So that one, I've only got 45. So let's see what's going on over here. So this one gets drawn in the negative sections. 71.6, 71.6. So again, starting at 0, I go along and I've got 180. And I'm going to subtract 71.6, which gives me, it just disappeared off my calculator, which gives me 108.4, and to the nearest number, that would just therefore be 108 degrees. So that is one way to solve this one, but there is a different way if you hadn't spotted it, and this one is a little bit trickier to do. Okay, that was the easiest way, but yet your answers are 45 and 108. Let me show you the alternative way. So I'm just going to erase this line. I'm just going to make a note that we did have tan theta equals 1 and tan theta equals minus 3, because I'm going to show you a different way that you could have got to that line. Okay, all of this getting deleted now. But if you do need to see it, of course, it's on the video. You're welcome to rewind it and see it. And there we go. Goodbye. Disappear. Okay. The alternative way. What some people would have done was change the sine into a sine over cos. Now, because I don't like having this denominator, well, first of all, I'll do the numerator. That is a sine squared. Now, most people don't like having this denominator, so what I'm going to do is I'm going to times every term by cos theta. So on the first term, it cancels out. On this term, I get sine theta cos theta. And then over here, I get a 3 cos squared theta. Now, this is a trickier method if you went down this route, because I'm not going to use an identity to start changing the cos squareds into sine squareds or the sine squareds into cos squareds because of the middle term. There is a mixture of both. It doesn't work. The reason why this one is harder is this, you're actually going to have to factorize. Okay, and I'm going to factorize it first and then tell you why it's correct. This is the factorization. Sine times sine is sine squared. Sine times minus cos is minus 1 sine cos. And then I get a plus 3 sine cos. And 3 sine cos take away 1 sine cos gives you 2 sine cos. And then you've got 3 cos theta times this gives you the last term. Now, if you didn't quite understand what I said there, do FOIL on that. And you'll actually see it's the right answer. And as it's a quadratic, that means, I said this is the long way round. Either that equals 0 or this equals 0. So what I would do from here is I'm just going to move this term across. And if I divide both sides by cos, I then get tan theta equals minus 3. which is what I had on the previous slide in about 2 lines. But I can divide both sides by cos to get that. And in a similar vein, over here, the cos can move across. And if I divide both sides by cos, I get tan equals 1, which is the other solution I got at the top. Now, yeah, that way is the much trickier way, so I would advise probably against that one, but you can do it that way. So it's better to try and think of it. Sometimes you have to have a good think about which is going to be the easy way to do it. So I would suggest you have a go at the practice questions that are attached to the Google Classroom. If you have any questions, either message me on this Google page or talk to your maths teacher. I hope you found this video useful.